friends, we start with lecture 13 of Math 303. As per my notes, we start with 6 of unit 3. Find the image of the strip 1 by 4 less than y less than 1 by 2 under the mapping omega equal to 1 upon z. So this strip is this is x-axis, this may be y-axis, origin, and 1 by 4. This is y equal to 1 by 4, y equal to 1 by 2. So, actually we are talking about this, and we wanted to find where it maps. That we want to find. Here 1 by 4 is less than y and 1 by 2 and y is less than 1 by 2. Therefore 1 by 4 is less than we just put the value of y. Less than 0. Less than 0, so we multiply by 4 times u square plus v square. So we have this. U square plus v square 4v. I add 4 on both these sides, so it is so this is a circle having center 0 minus 2 inside the portion of circle 0 minus 2 and having radius 2. So actually this strip will measure into 0 minus 2 as a center, this is u axis, this is v axis, this is origin of the image, and inside this is measured by this portion. And here, if we apply the same thing over there, then what we have right now? I make space for me to write, nothing more than this about this diagram. There is nothing mathematics in this one. So, minus v u square plus v square less than 1 by 2. Then I put it all these things in the one side. Then I multiply it by 2 times u square plus v square. Add 1 in both this side. So if we add 1 in both this side, what we will have? This is a circle having center and radius, outside portion of radius 1. Means at this time The center is 0 minus 1 having radius 1 and outer part. So this strip maps into this portion. Try to get familiar with this and then we go further into one more sum. Okay, now we introduce one more definition of Mobius transformation. How we write Mobius? On O, we put two dots at there. This is the symbol how we write Mobius transformation. The another name of this transformation, you may find it here in my notes also, and that is bilinear transformation or linear fractional transformation. So there are three names of this one. Z is complex number, omega equal to az plus b, cz plus d, a, b, c, d, all these are complex numbers. Where AD minus BC not equal to 0, then this transformation we call Mobius transformation. Clear? Then find Mobius transformation which maps Z1 equal to minus 1, Z2 equal to 0, Z3 equal to 1 on 2 points omega 1 minus I, omega 2 1, omega 3 I. Means which maps Z1 into omega 1, Z2 into omega 2, Z3 into omega 3. Means these 3 points maps into these 3 points. So we start with, suppose this is Mobius transformation. Az plus b, cz plus p. This is our supposition and we wanted to find the values. So we start with the middle term. Z2 0, omega 2 1, and therefore equation 1 implies omega 1 Z0 Z2. So this is 1 equal to 0 plus b, 0 plus b, and therefore it is b upon d, and therefore b and d are same. So right now, what is omega? Az plus b upon cz plus b. We replace capital small d by small d. Then z is minus 1, then omega is minus I. I put this value here. Minus a plus b minus c plus b, and therefore ci minus id is minus a plus b. I say equation 3. And the other value is z1 equal to 1, z3 equal to 1, omega 3 equal to I. We put these in equation this one. So I equal to a plus b upon c plus b. So if we put this value here, I, a plus b, z is 1, c plus b means ci, bi, is A plus B. We find this equation after this one. Now adding both these equations, what we have, 2Ci is 2B and therefore Ci equal to B. So this is equal to minus I square B and therefore value of C is minus IB. Now we put this value in any of these equations to find the value of A. Therefore, what is A? Ci Bi minus B. But value of C is IB with negative sign and therefore this is I square B, but that I square is minus plus 1, minus I square is plus 1 and therefore minus B plus B will be cancelled and therefore this value is equal to Bi. Now we put these values in this equation. So this is equal to A, that is B I Z plus B minus I B Z plus B. So I Z plus 1 minus I Z plus 1. So this is equal to IZ minus I square minus IZ minus I square. 1 is minus I square. Now we cancel out 1I. This is equal to Z minus I minus Z minus I. So we cancel out numerator from denominator and numerator. So this is equal to I minus Z upon I plus Z, and that is omega. By this minus sign we change the order of in the numerator and therefore it becomes I plus Z. So this is your final answer. Here I want to emphasize something for you. Take Z1 equal to minus 1. If you put Z1 equal to minus 1, this becomes I plus 1. And in denominator it is I minus 1. Is it? Now, this is minus I square. This is plus I square. One minus I, 1 plus I. Now again put the values there, you will find that omega 1 is I. Put these values there. You will find that the values are equal as we wanted. Z2 equal to 0, the value will be 1. This equation. Okay. See here, in this sum, if we take z1 equal to 0, means the second value, this is answer. Then this is I minus 0, I plus 0. So it is I upon I, and therefore omega 2 is 1. Clear? Now if we put z1 equal to minus 1, means z1 equal to minus 1 means it becomes I plus 1. Here it is I minus 1. I plus 1 I multiplied and divided by this term. So it is I plus 1 square, and in denominator it is I square minus 1. A minus b, a plus b. This is minus 1, this is minus 1, so it becomes minus 2. Simplify this, it is I square plus 2i plus 1. So 1 and minus 1 will be cancelled. So it is 2i upon minus 2, therefore minus i. So this value is minus i. In the second value, z equal to 1, omega 3 is I. How it is? I minus 1, I plus 1, I multiplied and divided by this term. So in numerator it is I square minus 1, a minus b, a plus b. Simplify this, this is minus 2, minus 1 plus 1 cancel, so it is 2i. Minus 1 upon 2 will be cancelled, so it is minus 1 upon I. So it is I square upon I. Minus 1 is I square, and therefore this is it. Here, so it is like this. Friends, we start with example 11. And there also we want to find Mobius transformation. But z1 is 1, z2 0, z3 minus 1. But new thing is that there is I infinity and 1. So infinity is very different number for us, but we make it very easy by doing this. See here. Here it is. Means numerator to denominator, denominator to numerator. And the second value, z2 is 0. At that time, omega 2 is infinity. We put this value in this equation, what it will become? 0 equal to d upon b, and therefore d is 0. So we have omega equal to az plus b plus cz. Now there is no d because value of d is 0. The another value, z1 is 1, omega 1 is I. I say this as equation number 2. Therefore, I equal to a plus b upon c. We put these values at there in equation 2. Therefore, Ci is a plus b. Equation 3. The last value, z3 is minus 1. Omega 3 is 1. We put this value in this equation. So, it becomes 1 equal to minus a plus b upon minus c. And therefore, minus c is minus a plus b. We derive it from this, and I say this is equation number 4. Now adding both of them, Ci minus C is 2B. This implies V equal to C by 2 into I minus 1. Now if we put this value in this one, the value is Ci minus B because of equation 3. And therefore, Ci minus I minus 1 by 2, we put this value of B and then Ci minus I by 2 into C, minus minus becomes plus C by 2. So this is equal to Ci by 2 plus C by 2. So this is equal to I plus 1 by 2 into C. This is value of A. Now we put these values in this equation. Omega is Az plus B upon Cz. You know that value of D is 0. Now we have value of A, that is I plus 1 by 2 C Z. This is value of A. Then value of B, C by 2 I minus 1 upon Cz. So this is I plus 1 Z I minus 1 upon 2Z. This is value of omega. I plus 1 Z I minus 1 CC will be cancelled. This C and the C in the denominator. So it is I plus 1 Z I minus 1 and this 2 of denominator we multiply with denominator Z, and therefore this is your answer. Now you can verify this as I have verified it in the previous class. Put Z1 equal to 1. Will you get omega 1 is I? Z2 equal to 0. Put, will you get omega 2 infinitive? Put Z3 equal to minus 1. Will you get omega 3 is 1? Check it. This is correct answer. Definitely you will find your answer. Dear friends, with this I stop here. Thank you very much.